In this video, we're going to run through the tests required for validating this workstation. Validation is required after manufacture, after installation, and after any repairs that are made. Okay, this is the light intensity test. You place the sensor probe in the geometric center of the work surface. It is 46 centimeters by 29 centimeters. Turn the meter on. Wait for it to stabilize. 63 lux. Okay, next you want to take a measurement 30 centimeters from the geometric center to the left and right. Getting 64 lux. 63. Another way to check to see if you have enough light is to be sure that you can read any paper that might be inside the cabinet. Okay, we're going to measure up 1 meter from the work surface. And then at that point, you're going to come out 1 meter, which is out here. I need to raise this up all the way. Okay, you're going to take it in the center cabinet. 43 dB. If you don't have a sound meter, you need to be able to hear someone's voice that's maybe a meter away from you. Okay, this is the vibration meter. And again, you want to place it at the geometric center of the work surface. Okay, you want to wait for your meter to stabilize. About 0.2 displacement. If you don't have a vibration meter, here's another test you can do to monitor your vibration in your cabinet. Just fill a beaker up with some water, maybe 3/4 full. If your cabinet is made to the right standard, you should not have any rippling on the surface of the water, like this. Okay, this is the stability test. It's to ensure that the cabinet's design is durable, robust, and has a resistance to deflection. Okay, one method to check for the stability is with a square on a parallel surface. Push the cabinet and it should come back to the original shape. Okay, the next test is to measure the intake velocity. We're going to take a series of measurements, one in the geometric center of the work access opening, and then also in each of the 4 corners. In each one of the four corner measurements is between 50 and 55 millimeters from the wall, and also up from the bottom or top edge. So I'm going to set it up now for the geometric center. Turn on our meter. The air flows into the direction of the dot that's placed on the hot wire anemometer. .38 to 0.39 meters per second is the first measurement. Once you've measured the 5 points, you need to take the average, and it should be 0.4 meters per second or more than that. Okay, next we're going to look at the smoke pattern of the cabinet. Smoke should be introduced along the perimeter of the access opening about 4 centimeters away. There should be no smoke exiting the cabinet once it enters. In addition to running the smoke along the perimeter of the access opening, we want to position the smokes 15 centimeters behind the edge of the view screen and run it along a straight line from left to right. You want to be 15 centimeters from the access opening and behind the sash. No smoke should exit the cabinet. Okay, to do the smoke pattern test, if you don't have a smoke generator, you can light a small stick or use a matchstick to generate your smoke. Okay, this next measurement measures the static pressure in the exhaust duct. What we're going to do is to measure to make sure it has the proper exhaust flow. You want to make sure that you have enough negative pressure or enough negative static pressure to give you the correct intake velocity. So this needs to be high enough. And to measure this, we have it's called a U-tube manometer, and it measures the air pressure when you attach a hose to one end and attach the other end to the exhaust duct. It's going to displace this oil in this tube and cause it to be offset from zero. So I'll demonstrate that by attaching the tube to one end. And the other end of the tube we will insert into the exhaust duct where it's 8 inches in diameter. You need to insert this approximately 1 or 2 millimeters. And then you'll notice that the oil has been displaced. This oil here has been drawn upward because you have negative pressure at suction. So it's drawing the oil on this side upward, and it's causing the oil on the other side to go down a little bit. And it's moved it approximately 1 small division up and 1 small division downward. So it's approximately 0.2 divisions displacement. And I'm going to remove it, and you'll see this will come back to even.